Hey everyone, welcome to another video in the Master Data Management in SQL series. My name is Elric. In the last video, we were finally able to get our columns into the data point table. And in this video, I'm going to kind of mimic what we did in 4 and 5. We're going to add another shape to our arsenal. And this is the relationship shape. Now, the relationship shape consists of a realm, a class, a family, a type, and a relationship table that has a different design than our base table. So, due to technical difficulties, this will be the second take, but you know, things happen. So, what I did, well, first of all, I'm gonna get started. You can follow along if you'd like, or just watch. Either way, we're gonna have some fun. So, the first thing I wound up doing was adding a record to my subject table under system, or under the CFTB shape and system relationship for the key name and the name. After I added that record, I just went up to the procedure we created during that video and I executed it. Like I was talking about in the data point video, we don't have any if checks, and that's okay. That's why I wrapped it in a begin try, end try. In order to get those checks done, we're gonna do it in a data-driven side. This is, we're gonna get this done fast, and some of these tools help us build other tools better. But we have to spiral out and create these different things. So after I ran that, I should have a CFTB shape for the system relationship. And what I'm going to do is I'm going to generate two scripts through SQL's generate objects. I'm going to generate these separately, but I'm going to highlight the system relationship CFTB that we created. And by default, it's going to script as create. So I'm going to create it to a new window, and then I'm going to hit the back button, go to advanced, and script as drop, and save it to a new window, hit finish. So we're going to drop this first, and we can go ahead and close that out. So now, this is our CFTB shape. And I want to come in here and make some modifications. So, how do I want to do this? So separated them out. Okay, that'll be the way. So when I scroll down to my alter table, I have all these system relationship class items. You can see right where it breaks from the base into the class. I'm going to start at the class, and I'm going to go down until it breaks to the family, and I'm going to highlight it and run a replace. Come on. There we go. And I'm going to replace class with realm, because that's going to be our new top. And then if I go to the end of that script, we run into the family. So I'm going to highlight the family piece and copy it and paste it in between the realm and the family, and then highlight it again. So in this piece, we are going to replace, once again, class with realm. And then we're going to replace family with class. Because essentially in the RCFT-R shape, the C and the F, the class and the family, and even the type, they're all the same looking table. So this is how I want to create my class piece. And then I'm going to go down and find the relationships, the foreign keys, for the family to class. And I'm going to copy those, paste it, replace class with realm, and family with class again. And what I've mimicked is, the family to class relationship, the class having the cluster group. Now I have a family to class, a class to realm, where the realm has the cluster group. So I have a foreign key from type to family, family to class, class to realm. So now we have the bottom piece done. We need to actually modify the table. So if I scroll all the way up, and essentially I'm going to do the same thing. I'm gonna highlight the class table, replace class with realm, and then I'm gonna highlight the family table, paste it between the class and the family, replace class with realm, and then family with class. So I'm going to save this script. Just so I have a copy of it in case we mess up during this, in case I mess up during this. But I'm going to execute it. Awesome. So now my shape has changed. I have a realm. My class is a foreign key to realm. My family is a foreign key to class. Type as a foreign key to family. Relationship as a foreign key to type. So our RCFT is perfect now. But our base table needs quite a bit of modification. So I'm actually going to design this table first, because there are some things we need to change about it. Now, the first thing I want to change is that the relationship table is no longer under the reference file space or subject family. It's under the relationship subject family. And there's a very specific reason. The relationship gets its own file spaces like we recreated in video 2. And it's because the relationship changes a lot and it's very large. Like even my testing environment at my current place of work, we only are working with 62 million in our relationship table. It's extremely fast, but it's very large for in terms of record size when you think of relationships in small and medium businesses. So so the primary key no longer is ref, it's rel. Now the other thing I want to do is I'm actually going to remove our descriptor columns, because we aren't describing a relationship through text. We're describing a relationship through parents and children and the type structure that it belongs to. So I'm going to remove those. And number 2 is that we don't clean relationships. We don't need to. We can create and remove relationships a lot easier than we can clean them, because we don't want those 62 million to turn into 124 million and so on and so forth. That's just not good. These are just relationships. We can store them, we can track their history if we need to undo it, but these are just relationships. Now, these are the columns that are in every single table in my system. This set of columns right here: a primary key, a tenant, a dataset number, a taxonomy or cluster, displays, availability flags, and spoke flags. For the relationship side of things, the relationship shape, we need to add 4 columns. We're going to add a specific data set, that should say number. Parent implied. And how I name my columns is, this is what the value is. This is why it's in there twice. And the underscore implied lets me know that it didn't originate here. And that is also why I created a unique data type for it. There's going to be no nulls with a null default. The second column is the int row ID parent implied. And that's why I created the foreign key implied data type. This is going to tell me that this is a system generated column that exists somewhere else. And this is also why I have this under a different family. I actually have a family of implied for my data point family. Because I want to make sure that I know what table has implied columns, because we have to treat them differently because they exist elsewhere and we need utilities to check on if they still exist elsewhere. So same thing, null, no nulls, and a null default. And what I like to do just for design is I like to split my parent with my child, or split my parent and my child by the display order and sequence columns. I guess it's just easier for me to read, so I can look at a parent, and then I see a sequence and it says 5, and I know I'm in the specific type of relationship, so I go, oh, okay, the parent is 5 above or 5 below the child, instead of going, oh, parent and child, and here they are 5 up or 5 down. And it's just a personal preference. But this should be the order because this is our cluster in this order. Well, this is come on, shift, there we go. This is our cluster in this order. So the other 2 columns are the child versions of the 2 columns we just entered. And essentially what this is doing, or what I am doing here, is the specific dataset number is a unique dataset number given to every single dataset in our system, whether it's a view, an Excel, a TXT, a table. Those are sets of data. So that means in any table, I can relate any record, or let's say, I can relate any record in any table to another record in any table. That's the power of this relationship with an amazing cluster, so it allows us to keep those relationships close together. So people to a people, a type of relationship could be a father-son, like a biological relationship. It could be an employee-manager relationship type. It could be I think you are the same person relationship type, where if you can identify, like if I have two applications running on the same database and I have two users in these different applications, but their email's the same and their name's the same and they live really like one of the addresses is incomplete but the other one is mostly complete, their zip codes are the same, I think that might be the same person, so I can create a relationship between them. And even better is through multi-tenancy, I can create a new tenant and call that like, hey, here's my test aggregation tenant, and combine them and treat them as one in testing models and see, hey, or ask, if these truly are the same people. That's why when you, what's that thing? You filling something out and they're like, hey, can you verify who you are? Have you ever lived on this street before? That's essentially what we can do here with using this model, multi-tenancy and using the relationship table. So that is my goal. Maybe not that far, that's some serious mathematics, but that is the ability or the limitation in the system. The limitation is so far out there, matching and merging, that really anything in between that and nothing we can accomplish. So that is my relationship table, and I'm just gonna save it, and I'm gonna script as drop and create because we have to fix a couple things. So I'm gonna drop it, delete the drop, and then just make sure. Here's what I like to do. I like to highlight and replace ref system relationship with table rel system relationship. Oh, make sure it says current document. There we go. And then the second piece is we have to go to the type, because it will mess up the type, or it should. Maybe if I had TBL it didn't do that. It should have. Yeah, it did right here. So then I go back and I replace rel, there we go, rel system relationship type back with ref. And that should really give us the full change that we need. And then it's something as simple as replacing reference with relationship. So then I can just hit refresh, and that is that is our realm, class, family, type, relationship, shape. So the realm, the class functions like normal, but the realm, actually, let's just fill in some things that we're gonna use in the future. Let's say I'm gonna say this is a group 2 people relationship. Actually, no. We're not going to fill that in. The only types of relationships that are going to make sense don't belong in the system. We will get to simple default and data point type relationships here shortly, but the group 2 people and avoiding recursive CTEs, that's going to happen when we get to the core. So our next spiral, when we can actually get to the domain shape, that's when this is going to come into play. So I do apologize. Instead, we're going to tokenize these, and actually we're going to edit our subject table, and we're going to change this to the relationship shape. And then we're going to tokenize these, wrap this in like an automated process, and then see if we can create the second one. So to do that, we first need to script again, create our relationship table. And I think that is all I will need. Yes, I believe this is all I'll need. I'll be able to modify the other procedures. So, system relationship with subject name, just like in video 5, and system main with database name and database type name. Because it's been a while, we didn't have the database table up and ready yet, so we had to split them apart. Now, I'm not going to replace go and replace the other flag. I'll just do this manually. 2, 3, 4. Up. 1, 2, 3, 4. Okay. So now I'm going to head back over to interface main, and I guess I'll just open up class no realm, and I'll open up base. We'll replace base. Yeah, because it has no taxonomy attached to it. So I'm just going to look for the if exists and replace TBL ref with TBL rel. Go back to my script, copy my pieces. And we're going to save it. Make sure not to get that go. Boom, boom, some indents. And then we're gonna do create relationship. All right. Now we have our relationship. I'm going to go back to the class no realm. I believe I should be able to replace class with realm. And then remove the word realm, because that's the shape. Yep. Oh. Create. I'll just remove that description, and that's today. So now I will open up the family. We're gonna do create, and instead of create family, we're gonna say create class with realm. And I'm just going to highlight my scripts, replace class with realm, and family with class. And that looks good. Oh no, not anymore. This is take 2. I'm actually have my mic on this time. There we go. And there we go. So that's how easy it's gonna get. we're going to run into basically two design patterns. Creating certain things is going to get very easy and allow us to work really fast. But then creating things that will help control our system, they're going to get longer. Simple, just longer. So I have my relationship, my realm, my class with realm, my family, and my type. So that means I can modify my all class family type base, do all realm class family type relationship, create necessary RCFT-R, RFCT-R, and reference becomes relationship. This doesn't matter anymore. And then, actually, for comment purposes, replace base with relation. Underscore base with underscore relationship. We'll just copy the family piece because we're just going to change the word family. And instead of class no realm, I'll do the same thing. Highlight, replace no realm, replace with realm. Control R, Control Shift R. Okay, I'll paste that family code I copied up top. Replace family with realm. So that should be how we automate, for the most part, our relationship shape. So that means that in my subject table, I would have now asked you to enter in system reference relationship and then run our all realm class family type to see if it works. Cannot create a constraint. Hopefully that's just the first one. Yeah, buddy, and it works. So these are the two relationship tables that I have in the system table. In the core, we have core relationship and core reference. And in atomic, we have atomic relationship and atomic reference. Now, I don't really use the atomic one very often, but the core and the system ones are used all the time. Very heavily. System, not so heavily. Core, yes, very, very much so. Now, here's the difference between the two. I say relationship gets its own file because it's not reference data. It changes a lot. It can change a lot. Reference data doesn't change a lot. And since reference data doesn't change a lot, I've actually decided to create a set of tables, the reference relationship, that are only used to relate reference tables to other reference tables. The normal relationship, the system relationship or core relationship, just the relationship structure without the word reference, that is meant to relate changing data to unchanging data and changing data to changing data. So domains to domains, which will be the, we're kind of going to have to create two shapes at once, but the domain shape, like people and group, relating those two objects together, they're going to be in the relationship ones. Relating Data point type to a definition. And that's going to be in the reference relationship because they are not going to change very often. So that is the reason for these two different shapes. And hopefully, just with the explanation on how my relationship table is structured, hopefully you're either going, holy crap, that is awesome, or I can't wait till you fill that up because I want to see it crash. And I'm sorry to disappoint you in advance, but this thing is fantastic. So when you think of the was it Boyce Claude BCNF, where the example was like it was like pizza and toppings, and then it was toppings and location, and then it was location and pizza. It was like, I think this is BCNF, normal form example. And it's like, oh, this is how you achieve true relationship. You almost have a triangle relationship because you can go from any direction to any direction. Well, with my with my relationship table and a wherein, it doesn't matter. I can make a hexagon if I wanted to, any shape. Triangles, squares, five-way relationships where we stack one type on top of the other. Like, give me the descendants, all the people under this specific group and their groups, where, you know, their family is ancestor over here, where in, and just keep piling on the relationships because of our clustered index with our parent and child. We're essentially just stacking the same small bits of disk space together, and it is insanely fast. It is insanely fast, and I will demo that to you once we get into AdventureWorks. But yeah, so that is our relationship shape. Please comment if you have any questions about how this works or if something didn't make sense. This is the most important shape in the entire system. By far the most important piece. So I'm going to end it at that. And our next video, we're going to circle back to the database and we're going to create synonyms. So we're no longer calling system. Interface main is meant to call synonyms only and not know where other databases are. So we have to remove that name part from all of our code. So our next video, we're going to create synonyms, remove that name part. The video after that, we're going to repair all of our tables specific dataset number stuff, so we can actually create relationships and get all of our clustered indexes and our files and all that good stuff on the right spot. So we're going from synonyms database back into data sets files for the specific dataset number, and then back into data points, data point types, or data, where it's our defaults and that sort. So thank you once again for tuning in. My name is Elric, and you have a good one.